So in this video, we're going to try and calculate the integral of sine times cos, both of x, with respect to x. So this is going to require the integration by parts rule, simply because we have x's tied up in two different parts of the equation, but then those two different parts are multiplied together. So this here is the rule we're using. You can see that we need to select a part for u and a part for v dash, and then we're just going to end up substituting into the right-hand side. So I would suggest it doesn't particularly matter in this case which one we pick as u and which one we pick as v dash. So I might just do it in order, like this, and we'll do a little sidestep of figuring out the derivative or integral of each one of these parts. So let's say we do the derivative of this one. All right, that's going to go to u dash. The derivative of sine we know goes to cos. So we're going to want to go back up the chain and figure out the integral here, so we get v on its own. And what I would suggest is that this needs to go to sine of x. And you can always do a double check. If you take the derivative, it should go back to what we have here. So the derivative of sine goes to cos, all seems to work out. So now let's go ahead and actually apply our rule. So the rule is the integral of uv dash, which we've let to be sine and cos, is equal to u times v, so we can do that here. So we get sine x times sine x, minus, we've got to take the integral of u dash, which is cos of x, multiplied by v, which is sine of x. And it's all with respect to x. So we can do a little bit of cleaning here. So sine x, you could write this as sine squared x, but I'll just leave it in its expanded form. And here, I'm just going to swap the order of these over, which is just cosmetic. Okay, so we end up with sine times cos inside our integral. Now the trick for this one is to identify that actually we started off with the integral of sine times cos, and that's really what we're trying to find. So if I just copy this down here, what we can do is actually kind of put these two together and like amalgamate them, because you can kind of think of them as like a term on its own. So we have the integral of sine times cos with respect to x. If we shift this to the other side, it's going to become plus, and it's the same thing. So we're going to have two of them. So 2 sine x cos of x dx. And it's just equal to our sine times sine. So finally, all we want really is the integral of sine times cos on its own, which corresponds to this piece of the equation. So if we shift the 2 back to the other side, which just means dividing by it, we end up with that. And because this is an indefinite integral, we need to make sure we have our little plus c on the end. Now, again, you don't need to write it out in long. If you did want to, you could put this together. So sine of x all squared. And sometimes as well, people will write this with the 2 just after the sine, which means the same thing. But all 3 of these answers are now correct. So that's all there is in terms of this video for finding the integral of this particular function using integration by parts.